Here is a question on geometric representation of vectors, and we will do some minor calculations here to understand the topic. Question number 4. Peter drove 8 km east, then 6 km south. A. Draw geometric vector to represent the displacement. B. Calculate magnitude of the displacement. C. Calculate the bearing of Peter's car to the nearest degree. Okay, so let's try to do these problems. I will suggest you can stop the video, make an attempt to do them, and then look into my suggestions, right? Here are my suggestions. To answer this question, let's make a coordinate plane. We have east and south directions, so a coordinate plane will help us to solve this problem. So east and south, will give more room to the right side. So Peter drove 8 kilometers east, then 2 kilometers south. So first part for a geometric vector is to choose a proper scale, right? So since it is 6 and 8, the common factor is 2. So let's take a scale of 2 here, right? So if they say 2, 4, 6, 8, 10, correct? So we can have 2, 4, 6 like that. 2, 4, 6, 8, 10. So kind of we have a scale now. Once you have a scale, then you draw geometric vector. Geometric vector means you have to represent it with a line whose initial position will be a tail and head is your final position or terminating position, right? So drove 8 kilometers east. So 2, 4, 6, 8. So that is the first arrow, right? We'll start from the origin itself, and that's the arrow. Let's call this point O, and so Peter reaches A, and that is 8 kilometers east, correct? Now let's go for then 6 kilometers south. So from here we'll go 6 kilometers south. 2, 4, 6, so that is kind of here, right? So 2, 4, 6 then goes south 6 kilometers. Let's call this point as B. So that is the geometric representation of our vector. Now it's very important, we have already given the direction, so I'm writing east here, north here, and we have west and south here, right? Now we should write here itself 8 kilometers, and this is 6 kilometers south. So we got now perfect geometric vectors. So that is the tail and the head, 8 kilometers south east, and tail and the head 6 kilometers south. Part B is calculate magnitude of the displacement. Displacement is final movement from starting point to end point. So as we can see, the two vectors were, we did here O to A and then plus A to B, right? We'll soon learn this addition also. So it becomes, as you can see, O to B, right? So O to B. So O to A to B is O to B, right? So when we add, we put the tail on the head, and then initial tail to final head is what you get. So that's what we have, and let's connect this, right? So let me connect this with a line here, dotted line, indicating that that is the final displacement. And now we need to find what is this displacement, right? So displacement we can calculate using Pythagorean triangle. This is right angles, right? So here this displacement will be square root of 8 square plus 6 square, right? So that is the displacement. Now you can use calculator and find your answer. 8 square is 64, 6 square is 36. I have purposely taken very simple numbers here so that we concentrate more on the logic. 6436 is 100 and square root of 100 is 10. So we get this displacement as 10 kilometers. So we got our final displacement, that is 10 kilometers. So we said, well, the displacement is 10 kilometers. And now we need to find direction. So let me write this as magnitude of OB here, since we have only found magnitude here for this vector. To really define this displacement, we should, and we have to, find the angle of bearing. Angle of bearing is part C, and that is this angle. From north clockwise. So from north clockwise, how much is that? To calculate this angle, let's first find this acute angle theta, which we can calculate using trigonometric ratio, tangent theta, right? Tan theta. Let me do this work here itself and mess it up a bit. So it is tan theta is equal to what? So tan theta is equals to, in this case, opposite, which is 6, over adjacent, which is 8. 6 over 8. So theta equals to tan inverse of 6 over 8, right? And let's use calculator to calculate this. So that gives us shift tan inverse within bracket 6 divided by 8 bracket close equal to 36.869. So let's round it. Let's round it to 37. Okay, so it is 37 degrees. Now that is the acute angle theta. So angle of bearing is how much? So let's call this angle of bearing as beta. Beta, right? So let me say beta equals to the angle of bearing is 90 plus theta is 90 degrees plus 37 degrees, right? So that's how it is. So, and we can add this up and get our answer. So 9 plus 3 is 12, so 127 degrees is our answer. Correct? So we can solve this problem in this fashion, correct? We haven't really taught you how to find magnitude and direction, things like that. But you see, with your own knowledge of trigonometry, Pythagorean theorem, you can still do it, right? So that's the beauty of vectors. I hope you understand and appreciate it. Thanks and all the best.